So, we've been on a quest for longevity for thousands of years, right? All the alchemists of the Middle Ages were trying to find out how to actually extend life and use different molecules and chemicals to create the fountain of youth. And we kind of haven't figured it out, except now we're on the verge of a revolution in science and medicine that's giving us the opportunity to truly understand the mystery of our biology in ways we have never been able to do. And it's a quantum jump. It's a massive paradigm shift, unlike anything we've seen in science and medicine ever before. And so we're in a moment now where we're beginning to understand the nature of creation, how we were designed, how our bodies work. Einstein said, I'm not interested in the spectrum of this or that element. I'm interested in the thoughts of God. The rest are details. So we're going to get into the thoughts of God. We're going to get into how we were designed and how we can learn to play with our own human biology and our interaction with our environment and with all the things we're exposed to throughout our lives to actually upgrade our health and our well-being, and not just live longer, but actually extend the quality of our life. Because who wants to spend the last 20 years in a nursing home? If you live, that's not the idea of longevity that I want to have. And my goal is I want to be 120, 180 maybe. It keeps changing. Maybe I'll hit 200, depends. But there's no biological reason that we have to age the way we do. And most of what we see out there is abnormal aging. It's not what is inevitable. And in my own life, I've experimented with, how do I reimagine aging? How do I reimagine my own aging? I'm 62 and I don't feel it. I can't quite believe it. I'm in denial a little bit, but I'm like doing everything I want to do. I can go heli skiing, I can go surfing, I'm learning new things all the time, because not only is it a mindset, but your body actually has the capacity to regenerate, repair, and renew at any age, even starting at 80 or 90. I saw my father start to dwindle in his late 80s, and I said, Dad, you need a trainer, and I paid for a trainer, and he was able to actually increase his functionality and his activity and do so much more. This is me at 40 and at 62. And you can see I was not overweight, but I wasn't exactly the fittest guy. Even though I ran, I did yoga, I exercised, I ate well, I've just learned so much more about how to actually optimize my biology that I know that I'm fitter now than I was when I was 50 and 40, and I'm going to be probably fitter at 70 than I am at 62. And I know it sounds crazy, but it's possible. Now, there are many places in the world where there are longevity spots. They're called the blue zones. And I've been to a bunch of them. And I recently went to Sardinia, which I spent a week there this summer touring around with a couple of women who were actually Sardinians themselves, and took me into the homes and to meet the people who were actually living the lives there. And what's so striking about Sardinia was landlocked. So it's been sequestered from the rest of the world for thousands of years. They weren't occupied by any other foreign power. It was just too difficult to get in and up into the mountains. And so they've kept their traditional ways, their traditional foods, their ways of living, their community that's really been untouched. They mostly shepherds. Goats and sheep are their sort of staple of their life. And they have some extraordinary things that they do that are different in terms of the food they eat. So they drink, for example, Cannonau wine. Now, Cannonau wine is grown from these Cannonau grapes, which are highly stressed growing up in the mountains. And the more stress a plant has, and we're going to talk more about this, the more stress a plant has, the more nutrients it has, the more defense mechanisms it has to protect itself. So the Cannonau wine apparently has benefits that actually help extend life. And then the cheese they eat is all sheep cheese or goat cheese. And they know that they have to feed their goats and sheep certain plants in order for the milk and meat to taste good, or for the milk and the cheese to taste good. Now, one of the people I visited, Olinto, said, "We flavor the meat before we kill the animal." I'm like, "What do you mean?" He's like, "Well, we feed the animal all these different foods and plants and acorns and this plant and that plant and this wild thing because we know it affects the taste." But what people then didn't realize is that taste comes from the medicinal properties in the food. And the medicinal properties in the food create health. So flavor and the medicine and the health all go together. And so there's incredible phytochemicals in the meat and the cheese and the milk of the animals they're eating. You think phytochemicals are just found in plants, but they're not. They actually are in the meat and the milk and the cheese of the animals who are eating these plants. And they know, oh, we're going to take our goats or sheep to this particular field at this particular time because we know that if they eat these plants, it's going to taste better. Well, what they didn't know was these molecules are molecules of healing and repair and rejuvenation and longevity. This is Carmine, who literally, we were driving behind him on this side of this mountain town, and he literally stopped the car, pulled over, and got out and kind of blocked us and just wanted to talk. And like you can see, we sat there for like an hour just chatting on this stone bench. He goes, do you want to come and see my farm? And in that village, there was an abandoned village that had been 500 years ago, had been built on this village, but then on the side of this hill, but then there was apparently going to be a mudslide, so they all had to abandon the village and they moved further up. But the village was still there, and he showed me the house he was born in, and then he showed me his farm. And I couldn't keep up with him. He was 85 years old, and he was racing up and down, going after his sheep. He grew a huge vegetable garden. He had fruit trees, figs, and pomegranates, and he had incredible array of vegetables, and he had chickens, and he had pigs, and he had sheep, and he was taking care of the whole thing by himself. And he was like 85 years old. I'm like, what do you do with all this food? He said, well, I give it away, or but he was so vibrant, and I literally could barely keep up with him running up the hill. This is Julia, who was 103 months. She made it very clear to me that she was 103 months, like a kid who says, I'm 5 3/4, and she was never married. That's her secret. She said. I said, what's your secret? I never got. She says, all my suitors all died, and I'm still alive. And she still works. She still makes doilies and little embroidery for weddings and various parties and stuff. And we had the best time with Julia. And she never had kids, but she doesn't live alone. Her nieces and nephews all live with her and take care of her. So nobody in those communities were alone. They were all connected to their families. This is Silvio, who lived on the top of this mountain, and he fed us this incredible meal. I had a little restaurant with his family. His family all worked together, lived together, lived literally thousands of years in the same spot, had 200 goats and sheep, and that's a minestrone soup, which is one of the staples, beans, and they put their sheep cheese in there and vegetables. And I said, Silvio, do you have any stress in your life? And he looked at me like I was kind of from Mars, and he thought for a minute, and he's like, well, yeah, I do have stress. Sometimes in the middle of the night, when the goat gets loose, I have to go and get it. or when it's calving time, I have to bring the female goats close to the house, and they wake us up in the middle of the night if they're giving birth. So, yeah, I have that kind of stress. Okay. This is Pietro, who is 95, literally just stopped being a shepherd about a year before, walked 5 miles a day up and down those rugged mountains, was upright, strong, and fit, and had a booming voice. I posted on Instagram him singing this song, and he was just the sweetest guy. And these people live in community. They live connected to each other. They eat foods that they've been eating for thousands of years, that are from the land, that are local. They help each other. They celebrate together. There's just a sense of richness, of connection, community, and living in the natural cycles of life. And they haven't really been acculturated to a lot of the Western traditions. And so there are these little hot spots around the world. In Sardinia, that's the place where they have the longest lived males in the world. There's Okinawa and the Nicoya Peninsula, and there's Seventh-day Adventists in Loma Linda, and Kari in Greece. And so there's this incredible hot spots that we learned a lot about the basic principles of longevity, but these people are living to 100 or 110. One couple, I think they were collectively 210 years old, which was pretty amazing. But the question is, how do we learn from them, but also how do we go beyond that to understand what we should be doing to not just have more life in our years, but have even more years than just even 100. And it's confusing, right? Because you've got, on the one hand, the Plains Indians, the Native Americans, at the turn of last century, they were the longest lived people in the world. There were more centenarians per capita in the Lakota than any other population. And they only ate buffalo, basically, and a few berries. And that was their diet. It was primarily carnivore. And the Seventh-day Adventists also are one of the longevity hotspots, but they're all vegetarians. So should we all be vegan, or should we all be eating only bison? How do we figure it out? Well, I'm going to explain how we can get to that. So it's not too late at any age to reboot your biology. We have the tools, the knowledge, the ability to actually access our youthful genes and our youthful biology at any age. And there was a study, for example, of people over 70 years old who were put on a Mediterranean diet and a walking program, and they reduced their mortality in half just by really simple interventions. Now, what is the limits of longevity? Is it 100? Is it 200? Is it 400? Is it 1,000? Methuselah lived to like 969. I think Noah was somehow 900 and something. Adam was pretty old too. So they all died pretty old in the Bible. I don't know what happened to us, but this is the Greenland shark, which lives over 400 years. And the bowhead whale, they recently found a bowhead whale that had a harpoon in it from the mid-1800s, that it probably was already an adult then, and it was probably a few hundred years old. There's the tortoises from the Galapagos that live well over 150 years, 200 years, and they don't even really age. So how do we understand the mechanisms of longevity, the biology of what happens? Right now in medicine, we practice what I call whack-a-mole medicine. We practice disease-based medicine. Now, when I went to medical school, we were trained in differential diagnosis. How do we categorize people according to their symptoms and put those symptoms in a disease category? So if you're hopeless and helpless and have no interest in sex and you don't want to eat and you feel like killing yourself, you go, I know what's wrong with you. You have depression. But depression isn't the cause of the symptoms. It's just the name of the symptoms. It's the name we give to people who share those symptoms. It could have 100 different causes. And you can have people with 10 different diseases, and they're all treated separately without any understanding that there's an underlying network of our biology that connects all of them. And this is whack-a-mole medicine, right? And I'll go through some cases, and you'll see how each individual is treated by different doctors for different things. I had a patient, for example, who came in to see me at Cleveland Clinic who had psoriatic arthritis. And she had, terrible joint pain, horrible skin lesions. She was on a drug that cost $50,000 a year. And she had irritable bowel, and she had reflux, and she had migraines, and she had depression, and she had insomnia, and she had prediabetes. And she saw the rheumatologist for the best drugs there. She saw the migraine doctor for the best headache drugs. She saw the GI doctor for her best reflux drugs and her irritable bowel drugs for her spasms in her gut. And she saw the doctor who was a psychiatrist who gave her antidepressants, and on and on and on. And they were all doing the best that they were trained how to do to treat that particular illness. But nobody asked the questions, what's underneath? What are the root causes? What is the underlying biology that drives these problems? So we have to reimagine human biology, human health and disease and aging. And the paradigm shift, it's as big as the earth is not flat, as Galileo saying the earth is not the center of the universe, for which he was put in house arrest till he died for saying something that was so heretical. It's the same as evolution theory, which says that our species evolved through natural selection, don't emerge fixed as they are, which people are still arguing about, and they're still flat earthers, And even quantum physics, think about that. We had Newtonian physics, which describes certain nature of reality, but it doesn't describe the true nature of reality. The chair you're sitting on is mostly empty space. Time is not linear. And the concepts we have about how things occur is really a false representation of the nature of true reality. So what is the corollary in biology? We're at this place in this moment of history in biology where we're finding out that there is an underlying organizing set of principles and framework and a theory for how biology works, for how medicine works. Up till now, it's been reactive. We just react. Oh, you have a headache, go to the head doctor. You have a stomachache, go to the stomach doctor. We don't have an overarching theory of how everything fits together. So what I'm going to lay out for you today is an overarching theory of how to understand our biology in ways that we can access it through different entry points in our lifestyle, in our way of living and being, through outside inputs, and have this incredible possibility of rejuvenation, repair, renewal, and longevity. Entropy is real, right? Entropy is the breakdown and decay that we see all the time all around us. So why should we think we're not subject to that? Well, we are to a degree, but the truth is that entropy only happens inexorably in a closed system. We don't live in a closed system. Like, humans are not living in a vacuum. We're living in an environment where we're breathing air and drinking water and eating food and having relationships and exposed to stresses and toxins and all kinds of stuff. So if we change the inputs, then we change the output, which is our health and our biology and our longevity. So it's a very incredible moment. So we have to completely rethink everything we're doing. And we need to do it in a freaking hurry because we are going downhill fast, really fast. I mean, this is a CDC slide that I've used in my talks for years. And every year I have to change it because it gets worse and worse and worse. First it was like 3 out of 10 Americans and 4 out of 10 Americans and half all Americans. Now 6 in 10 Americans have a chronic disease. 4 in 10 have 2 or more. And if you're over 65, over 80% have a chronic illness. Heart disease, cancer, lung disease, stroke, Alzheimer's, diabetes, and kidney issues, which are all connected. They're not all separate diseases. I mean, lung disease is primarily from smoking, but the rest are all totally connected. And so we're looking for the cure for heart disease, the cure for Alzheimer's, the cure for cancer, the cure for diabetes. It's complete nonsense. We're never going to find it. Why have we spent billions and billions of dollars of both private and taxpayer money to find the cure for Alzheimer's, and 99.6% of every single one of those over 400 studies has failed? And the ones that have succeeded basically prove that you can extend longevity in the sense of getting someone a few months more before they have to go to a nursing home. That's not success, right? 11 million people, and this is conservative according to the Global Burden of Disease Study, 11 million people a year die from eating the wrong food. It's the #1 killer today. Not smoking, not war, not narcotics, not poverty. Food is the #1 killer. It's because we're eating the worst junk, particularly in America. Why in America are we 5% of the world's population, but 20% of the COVID cases and deaths, and have the best healthcare system in the world, and spend more than twice any other nation on healthcare? It's because of this. 12% of us are healthy metabolically. That means 88%, almost 9 out of 10 Americans, are metabolically unhealthy, meaning they're on their way to diabetes, heart disease, cancer, dementia, because they have high blood pressure, high blood sugar, or high cholesterol. That's terrifying to me. So we can talk all day long about longevity, but unless we deal with the food and the food system, we're in trouble, which is why I wrote my book, Food Fix, basically how to save our health, our economy, our communities, and our planet one bite at a time, and why I started a nonprofit, the Food Fix campaign, to change policymakers' ideas and change policy, which, thank God, we just got $1 billion for climate smart agriculture, which seems like a lot, but it's really just a drop in the bucket. Now, we need to do this because while we're talking about extending life and longevity and all the shifts that are happening, we're kind of screwed. Even before COVID, we saw life expectancy start to go down in America. And with COVID, it's gone down even more dramatically, up to 3 years lower, which is a lot in African American, Hispanics, and about a year for everybody else. So we're in trouble. Now, we say historically we were never meant to live long. We weren't designed to live long, that we were, we had 30s and 40s, we'd have our kids, we were hunters and gatherers, we'd all die. Not exactly true. Yes, the average life expectancy was 40, but if half the population dies in childbirth and half lives to 80, life expectancy is 40. There were many people, John Adams and Thomas Jefferson, they lived into their late 80s and 90s. That was, back then. I go to cemeteries. My family used to go to cemeteries, these old cemeteries, and I walk around, and I look and see, and I was in Vermont. I went to the cemetery. This guy was born in 1700, and he died at 97. I'm like, okay. It wasn't that people couldn't live longer. It was that there were so many things that took people out, infections and trauma and war and predators. And the costs are staggering. The costs are, we spend $4 trillion a year in healthcare in America. It's $1 in $5 in our economy. It's estimated that over the next 35 years, it's going to be $95 trillion to deal with the cost of chronic disease that's almost entirely preventable. Can you imagine what we would do with that money? The Rockefeller Foundation came out with a report that says for every dollar we spend on food, we spend $3 in downstream costs and the effect on our health and our economy and climate and the environment and social justice. So we have to deal with this from so many aspects. Now there's a concept I want to introduce to you, which is the difference between lifespan and health span. Now who wants to live to be 120? And most people would say, no, I don't want to. I'm like, I don't want to live to be 120 because I see what happens to people who are old. I don't want to end up in a nursing home, decrepit and frail and miserable. But the truth is that you can have your health span equal your lifespan. Your health span is how many years of your life you're healthy. Your lifespan is how many years you're alive. So if you live to be 80, but you start getting sick at 60, your health span is 60 and your lifespan is 80. But there's a phenomena called the compression of morbidity, which is the idea that if you live well, you can basically die young as late as possible. And the idea, this was from James Fries from Stanford, who did a very pivotal study back in 1980. And he said, when you looked at these populations, if you kept your ideal body weight, if you exercised, and you didn't smoke, really 3 simple things, that not only would you live longer, but you'd live healthier. That instead of dying a long, slow, painful death, you'd die quickly, painlessly, and cheaply. And my vision is when I'm 120 or 150, I'm going to go up to the cabin on the lake with my partner. We're going to take a naked swim in the lake. We're going to have a beautiful meal, bottle of wine, make love, go to sleep, and that's the end. Right? That sounds good. So we can compress morbidity into this shorter period where maybe we just say goodnight to our family and we go to bed. And I've heard this story over and over. It's like, I'm done and I'm just going to bed and then I wake up. So we have that potential. You don't have to die from something. Now what's really exciting, and this is a little bit sounds sci-fi and crazy, but the top scientists are talking about this. David Sinclair at Harvard, George Church at Harvard, are talking about this phenomena called longevity escape velocity. And what does that mean? Longevity escape velocity means if we live long enough, the advances in technology and science and medicine will be exceeding the problem of death. In other words, if we live long enough to take advantage of these technologies, we can keep extending our life and longer, and maybe never die. Now, I'm not sure I never want to die, but I do want to see what happens if we can play with this realm of how do we reach longevity escape velocity. And in this course, I don't have time to unpack every technology that's out there and happening in the science, but there's so much happening at such a rapid rate. And what's exciting now is that for decades and decades and decades, science has believed that aging is inevitable, that death is inevitable. There's no point in studying aging really, because what are you going to do about it? We should study diseases. But the truth is, aging is a disease. As we see it, as we witness it in people, it's actually a breakdown in a set of dysfunctions that we've now identified and can modify through various interventions. And for me, the framework that I use to see the world through is something called functional medicine. Who's heard of functional medicine? So functional medicine is essentially not a new specialty or a new test or a new supplement. It's a way of thinking. It's a meta framework for understanding biology from a systems perspective. So we are an ecosystem. Our body is an ecosystem. Everything's connected. It's dynamic. It's interacting all the time. It's infinitely complex. And we had such a reductionist view of disease that we forgot to zoom out and go, whoa, how is everything connected? Right? We get into this very narrow specialty framework, which actually doesn't truly represent biology. For example, that psoriatic arthritis patient I mentioned, she ended up having all these different diseases which seem unrelated: migraines, arthritis, depression, prediabetes, reflux, irritable bowel, and she was seeing all the right specialists. And no one said, how are all these connected? Well, they're all connected by inflammation. Well, where is her inflammation coming from? Well, my logical guess was because of all her digestive symptoms, it was from her gut, because 60% of your immune system is in your gut. And so I said, why don't we clean up your gut? So I basically took out all the bad stuff in her gut. I killed the bad bugs that were growing in her small intestine that were fermenting and causing all this bloating with an antibiotic. I use an antibiotic. I'm not opposed to drugs. And I gave her an antifungal because she'd been on steroids and antibiotics. So we basically killed her gut and rebooted it. I call it the weeding, seeding, and feeding program. We weed out the bad stuff, and then we gave her probiotics, and we gave her some fish oil and vitamin D. We eliminated foods that are inflammatory, gluten, dairy, sugar, processed food. And I thought, she'll come back, she'll be a little bit better. She came back 6 weeks later. And I wasn't treating any one of her diseases. I was treating her system, not the symptoms. And 6 weeks later, she came back, and she said, everything's gone. No more psoriasis, no more arthritis, no more migraines, no more irritable bowel, no more reflux, no more depression. She lost 20 pounds, and she stopped all her medication. Now, I didn't tell her to stop it. I just said, stay on your medication until I see you next time. We'll figure it out. But she stopped it all, and she was fine. That's the power of understanding the body as a system. It's like when you know where to push, when you know where to pull in the system, it's all connected. It's sort of like what John Muir said, anything you pull on in the universe is connected to everything else, right? Now, what's happening at the same time as our understanding of systems biology is happening, what we call systems biology, network medicine. There's a Harvard scientist, Lakazi Barbazi, who wrote a textbook called Network Medicine, which describes this phenomena of having to reimagine biology based on what we now know. The complexity is staggering. I mean, how many chemical reactions do you think that are going on every day in the body? Every minute, every second? Every second, how many chemical reactions?
100 billion.
No. 37 billion. I don't even know what that number is. It's 21 zeros. I don't know if it's a bazillion or a quadrillion or a badillion, but it's a lot. And it's happening at the speed of light. So there's so many different things happening in your body with infinite complexity that's almost impossible for us to comprehend, nonetheless understand. But what's happening now is the convergence of biology and technology, right? There's our understanding of the infinite complexity of human biology. When you go to the doctor, you get some blood tests, right? You go, I got my blood test. He says, I'm fine. You get 20 things analyzed, 30 things, 50 things, 100 things if it's a very aggressive doctor. There's hundreds of thousands of things going on that we don't even measure or look at that are probably way more relevant than the stuff we're actually looking at. Because when one of those tests that your doctor measures is off, it means you're already screwed. Like if your liver function goes up, it means your liver is pretty damaged. If your kidney function starts to go up, you've already lost half of your kidney function, right? So it's only looking for people who are really sick. And it's great for people in the hospital who are struggling with extreme diseases. But for the rest of us, it's pretty meaningless. So where do we begin to look at these infinite complexity of biology? Well, that's what's exciting, because now through the omics revolution, we're literally able to get gigabytes and gigabytes of data on us. We can look at all the omics, like your genome, your epigenome, your proteome, your transcriptome, your microbiome, your sociogenome. There's actually such a thing as how our genes are expressed in relation to our social connections. If you're in a loving, connected conversation with someone, you're going to be turning on genes that promote health and longevity. If you're in a conflict with someone or you're stressed, you're turning on inflammatory genes. So you're literally, even cuddling, by the way, is great for your longevity, and it increases your epigenome health. So you've got the omics revolution, the systems biology framework. Then you've got the quantified self metrics, whether it's your Oura Ring or your Apple Watch or your Whoop or your Sleep 8 bed or whatever. Like there's all kinds of stuff now. We're actually able to measure continuous glucose monitors, and we're able to learn about our own biology in real time, not as one of a study of 1,000 people that may have nothing to do with who you are, right? Most studies are done on 70-kilogram white males from Kansas, basically, which doesn't apply to most of the world's population. How do you start to understand your N of 1, your own biology in real time? Because if I eat a plum, I might be fine, but if you eat a plum, your blood sugar might go skyrocketing with the same input. And then we have the capacity of big data and quantum computing, and then artificial intelligence and machine learning. These are all things that are happening simultaneously. So we're going to be doing, we call, our studies, for drugs, we do, in vitro studies, right, in the test tube, or in vivo, which is in human beings. But now we're doing in silica studies. Literally on silicone chips, we're able to do drug analyses and figure out molecules and how they work and do throughputs of stuff that we could never figure out before because we just didn't have the technology. So all this is converging at the same time, radically changing everything about how medicine's going to look. And right now, I'm going to suggest to you, my daughter's in medical school, and I'm kind of depressed when I listen to her because she's learning 20th century and often 19th century medicine. I'm like, God, and I told her, I said, I'm going to pay for medical school, but you have to read this book on functional medicine. And of course, she didn't, and I'm still helping. But actually, no. Actually, the truth is, she got a scholarship. Now, nobody gets a scholarship to medical school, but she was the #1 applicant, and I'm bragging because I'm her dad. She was the #1 applicant, got a tuition scholarship, so that was good. Now, what's more important than your genes? Because people are like, oh, is it your genes? Is it the environment? I got a bad deck of cards. Your genes is essentially your fixed software, right? But it depends on what you do in your life, and what you do determines which genes are expressed and turned on. Whether you turn on health and longevity genes or whether you turn on disease and decrepitude genes. And what we now know is that probably 90% of your health is not determined by your genes, but by the inputs to your genes. The inputs to your genes, we call that the exposome, what you were exposed to. And it's everything. It's every bite of food you take. It's activity and exercise. It's your sleep. It's stress. It's environmental chemicals. It's your microbiome. It's your emotions. It's your thoughts. Your DNA is listening to your thoughts, literally, not figuratively. It's extraordinary when you understand how you can modify your environment, and I mean environment in the context of everything that you experience throughout your life that washes over you. That changes in real time all the dynamic systems in your body. So there's a whole field out there called systems medicine, network medicine, complex systems in human health and disease, and therapy. This is exactly what's changing everything we know about medicine. The problem is the time from the understanding to the implementation is often decades and decades. And around the fringes of healthcare and the fringes of science, there's people pushing this envelope. So now you've got Jeff Bezos and Yuri Milner funding billions and billions of dollars for longevity research. You've got Calico, which is a Google spinoff, looking at longevity. You've got billions of dollars flowing in, not from the NIH. The NIH has a National Institute of Aging budget, which is about $240 million a year directly for aging, when you're looking at a $4 trillion phenomena. If you extend life by a year, and this is an economic analysis done by David Sinclair from Harvard and others, published in Nature Aging, you actually can save $38 trillion. If you extend life by 10 years, which is actually possible now, you save $368 trillion. That's a massive amount of money. Imagine what would happen if we had all that cash in the world supply. Free education, free health care, basic minimum wage, whatever you want. Clean up the environment, end climate change. I mean, it's an enormous amount of money that we're just throwing down the toilet because we're not addressing this. I mean, who have you heard in the United States talk about the reason that people have died from COVID is not because of the virus, it's because we're so unhealthy. 63% of deaths from COVID and hospitalizations from COVID could have been avoided by people eating a better diet. That's staggering. So when we think about aging, we think about the diseases. We think about, I'm going to get cancer, Alzheimer's, heart disease, diabetes, dementia. But here's the shocker. If we cured cancer moonshot, great, we should cure cancer. My sister died of cancer. My dad died of cancer. Great, I would love to cure cancer. Curing heart disease. My grandfather died of heart disease. If we cured cancer and heart disease, what amount of life extension do you think we'd have? If we eradicated them from the planet? Maybe 3 to 5 years. That's it. Nobody's living to 120 by getting rid of cancer and heart disease. These are all the downstream phenomena that are the result of upstream causes and mechanisms. And if we get to those mechanisms that are dysfunctional, they're called the hallmarks of aging, and then we go upstream from those to the causes of the causes, right? What is the cause of all these problems? We'll talk about these hallmarks of aging. What goes wrong in the body? But then the question comes, well, why does it go wrong? That's what functional medicine helps answer, is medicine of why, not what. So these are the things that we now are learning are what we call the hallmarks of aging, these phenomena that happen under the hood in all diseases. changes in our epigenetics, and we're going to talk about the epigenome in great detail in a minute. But essentially, the epigenome means epi means above your genome. Your genes aren't what matters. It's the actual epigenome, which is completely modifiable. Your genome is like the piano keys. You have 6 billion letters that make up your genetic code, A, C, T, G. They're called nucleotides. And they're fixed. You can't change that unless you do gene editing or CRISPR. So there are some advances that will change your genes, which is good for people who have genetic disorders. But it's the epigenome that's the piano player that's playing the keys. Which notes are played? Are you playing jazz or ragtime or rock or classical music? All from the same keys. And the beautiful thing about the epigenome is while you can't change your genes, you can change your epigenome. Mayor Adams, Eric Adams from New York City, had diabetes and was going blind and had all these chronic health issues. And he changed his diet, and his doctor was like, these things you have to live with for life. There's no reversing this. You're going to have to learn to manage it. We manage chronic disease. He said he realized it wasn't his DNA. It was his dinner. It was killing him, right? And that's the beauty of this. So we see changes in epigenetics. We see telomeres, which are the little caps at the end of our chromosomes that get shorter as we age. At the certain point, they're not protecting your DNA, and it starts to unravel. So it's like the end cap, and if that falls off, then this unravels. We have altered communication in our messaging and cell signaling problems. Our proteins start getting misfolded and actually damaged. And how do we deal with that? Our mitochondria, the energy factories, they start to degrade, and we lose the capacity to produce energy, and they become damaged. Our cells start to age. We get zombie cells, senescent cells that cause inflammation in the body and cause degradation and accelerate everything else. We have problems with nutrient sensing, meaning this is a very important part of hacking aging, is understanding how food and nutrients regulate different pathways that are longevity pathways or aging and disease pathways. And we now understand those. And that's where we're going to get a little geeky, but it's worth it, because a lot of things you're hearing, whether it's time-restricted eating, intermittent fasting, whether it's exercise or hot and cold therapy, how are these things working on our biology to extend life? So we have a really messed up diet, and that's really causing messed up cell signaling that drives changes in our nutrient sensing that regulate longevity and health. And then we have genomic instability. So with DNA breaks all the time, like thousands and thousands of times a second, your DNA is breaking. And you have a whole system of repair. I mean, you literally have within you these two systems that we're going to talk about that are the center of understanding how to create health and longevity. One is you have a demo and recycling system, right? It's like a house remodel, getting rid of old parts, breaking things down, cleaning all the junk out. And then you have a construction team, a rebuild and a construction team. And some people miss that, and they go, oh, let's just do the demo stuff. Like, let's just fast all the time. Like, no, you can't. You have to eat. You can't just fast all the time. You have to actually activate these systems in the right time, in the right way. Not too much, not too little. It's like the Goldilocks effect. How do you get to exactly the right amount of breakdown and buildup out of recycling and repair? How do you fix that? That's what we're going to talk about. Our stem cells get kind of pooped. So our stem cells age. They get changed in their methylation patterns. And so our stem cells start to age. So we have all these changes. And there's one more that I would add here is microbiome changes. I would add microbiome to this because I think it's really an important regulator of all of our health. And the microbiome is our gut ecosystem, and we'll talk about that. So meta to this, right? So these are the diseases, right? This is meta to that. Then what's causing all this? Well, that's where functional medicine comes in, because it's a framework, it's a meta framework for understanding everything. And I'm just going to spend a few minutes explaining this. This is literally a lifetime of learning. But on this one page, this is all that functional medicine doctors really need to understand in order to treat any problem. Every time I get calls from my office, they say, well, Dr. Hyman, so-and-so called. They want to know, do you treat this? He has this disease. Or do you treat that? I'm like, I treat the human body. It doesn't matter what you have. We'll figure out where things are off and out of balance, and we'll get you back in balance. And so the whole idea of functional medicine is creating this homeodynamic balance where everything is working in synergy and harmony your body is a network of networks. Basically, you've got predisposing factors, which are genes, stresses, traumas. You know, maybe your grandmother was in a concentration camp and that affects your DNA and your epigenome, or maybe you're exposed to some heavy metals like I was, or mold in my house, or Lyme disease, or maybe there's other factors that can trigger from the outside poor health, and we're going to go through what those are. And then there's your fundamental lifestyle factors, what you eat, exercise, how you handle stress, relationships, sleep. All these things are influencing these networks. So you either have too much of something that's causing an imbalance, an excess, or not enough of something that your body needs to thrive. And when you understand that health is all about taking out the bad stuff, putting in the good stuff, and activating your body's own internal healing mechanisms, then you have the keys to health and longevity. And so these 7 networks are your gut, your assimilation, your microbiome. And by the way, these are all connected. They're not like separate. This is a heuristic. It's just a tool we use to describe reality. It isn't the truth of all reality. It's like Buddha said, don't mistake the finger pointing for the moon itself. This is just the framework we use to begin to understand how to clinically navigate. So when I'm talking to a patient, I'm thinking, okay, what are those triggering factors? What are those lifestyle factors? What are the imbalances in these systems, in your gut, your immune system, your energy system, how you make energy, your detox system, how you process toxins, your transport system, circulation, and lymphatic circulation, your communication systems, your hormones, your transmitters, cytokines, and your structural system, from your biomechanical structure down to your subcellular structures. And how is it all influenced by your thoughts, your feelings, your emotions, your spiritual life? All of that is happening in dynamic real time all the time. And so as a doctor, I'm looking for, in a person's story, where are the clues? How does this all fit together? Like that woman with psoriatic arthritis. So we found a powerful new drug that we've discovered that has the power to positively influence tens of thousands of genes, to optimize hundreds of thousands of protein networks, to improve and regulate your immune system, to optimize your microbiome, to improve your brain chemistry. And it works faster, better, and cheaper than any drug ever discovered. And there's no side effects, just good ones. You know what it is? Food. Food is the single biggest signaling molecule that you consume every day. And food isn't just calories, it's information, it's code that programs your biology in real time. But like, I'm just gonna have this one thing, or I'm gonna do that thing. You're literally changing your microbiome, your immune system, your brain chemistry, your hormones, your gene expression with every single bite of food. And doctors don't understand this because they haven't been trained in nutrition. Even though food is the #1 cause of disease, the #1 cure for disease, yet doctors know nothing about food because they get no education about it. We were trying to pass a bill called the Enrich Act with Tim Ryan in Congress to provide money for medical schools to provide nutrition education. It's only going to change when they change the licensing exams. When they put 10% questions on nutrition, it's going to force the medical schools to change. So food is medicine. It's not like medicine. It's more powerful than anything you'll find in a prescription bottle. Because like I said, it's not just energy or calories, and it is that, but it's information, it's code. So think about your DNA as your basic software. Let's use Microsoft Word. Well, it has so many features. It can do so many different things, but it only does what you tell it to do. The same thing with your DNA. It only does what you tell it to do. You're either telling it to do good things or bad things, and if you pick the right foods, you're coding in the right way. Now, this patient is someone who was on her way to death. She was literally on her way to a kidney transplant and a heart transplant. She was 66 years old. She had heart failure. She had multiple heart attacks, stents. Her kidneys were failing. Her liver was failing. She had high blood pressure. She had type 2 diabetes. She was massively overweight, as you can see. Her BMI was 43, which is considered severe obesity. She was on tons of medications to manage her disease, on insulin for 10 years. She came into our program at Cleveland Clinic, which was actually a group program. It wasn't even a one-on-one program. It wasn't like we were using super high-tech advances in science and medicine except if you consider food as medicine, a high-tech advance. And 3 months, she was completely different. 3 days, she got off her insulin. 3 months, she reversed every single one of her diseases. Her blood sugar went from extremely high, like 300, 400, 500 to normal. Her blood pressure normalized. Her heart failure reversed, which you never see, by the way, in medicine. You never see heart failure reversed, but her ejection fraction improved from 30 to 50. Her kidneys improved. Her liver normalized. All of her other symptoms went away, and she got off her medication. That's the power of food. And this was her a year later, having lost 116 pounds, and she got her life back. Now, this person had been eating junk food her whole life. And when you think, God, it only took a year for her to get to this after a whole life of trashing her body, it just speaks to the power of regeneration, renewal, and repair, and the capacity, if you understand how to actually regulate the environment, to change your genes in the right way. Now, I was on a panel once with Craig Venter, who unpacked the human genome. He decoded the human genome. Brilliant guy. And he said 90% genetics. And I'm like 90% environment. So think about this. These are the Pima Indians 100 years ago. They lived vital, healthy, invigorated lives. They were thin, fit. 80% of their diet was carbohydrates, by the way. It was mostly, acorns and mesquite, and, they ate some lizards and rabbits that they could find. But basically, they ate a pretty healthy diet, and they were active. And they had no diabetes, no obesity, no heart disease, nothing. And then we showed up and provided the white menace, which is white flour, white sugar, and white fat, otherwise known as shortening. You know why they call it shortening, right? It shortens your life. And they started eating all this stuff, and they got what is commonly referred to on reservations, because these foods are government commodities that have been supplied to the reservations. It's like a second genocide. They call it commod bod. Oh, he's got a commod bod because he eats commodities. This is what they look like now. 80% of diabetes by the time they're 30. Their life expectancy is 46. It's like the developing world right here in America. So is it genes? Is it environment? It's both, but it's how your genes are expressed. Their genes are exquisitely adapted to starvation and scarcity. We have hundreds of genes that help us manage starvation and scarcity. Why? Because there was no Whole Foods or Costco a few thousand years ago, right? You couldn't find food in every corner, everywhere, every place. But now we live in an era of abundance, and our biology is not adapted to that. Now here's what's really amazing, and this is about the epigenome. So we thought it's all about the DNA. We thought that decoding the human genome would give us the answer to disease, would be the secret that unlocked the mystery of illness and help us to cure disease. It was a big fat failure. Big fat failure. Yes, we know more about our genome. Yes, it's helped us cure a few things and help understand things. But it's the epigenome that turns out is the most important thing, which is something we're just learning more about. And one of the first research to really look at this was Randy Girdle. Randy Girdle did this experiment on these mouse called these agouti mouse. And most of them are like the yellow mouse, a big fat mouse, which is hypertension and diabetes, right? And he said, gee, maybe I can reprogram their genes, their epigenome, by giving compounds that regulate the epigenome to the mothers before they're born. So they took genetically identical mice, two groups. One got the normal diet, and one got basically a diet that had factors that help regulate the epigenome we call methylation factors. Folate, B12, B6. Really fancy, advanced, expensive drugs, right? And this is what happened when the mice who had these methylating factors, and we're going to talk about methylation and DNA methylation, this is how we control the epigenome, were given these things that help silence the genes that were causing obesity and diabetes. They actually produced these little tiny brown healthy mice. Same genes, very different output. And this began really to help us understand the power of DNA methylation, of epigenome regulation. And this is basically how your genes work. So we'll do a little mini course on DNA, okay? Your DNA is your blueprint for everything. You have some from your mom and your dad. You've got 23 chromosomes from your mom, 23 from your dad. Each has about 3.2 billion letters. You combine them, you got about 6 billion letters of your genetic code. And a computer is a 1 and a 0. And think about what computers can do, virtual reality, do all kinds of cool stuff. Your biology is infinitely more complex. It's a quaternary code, which is exponentially more complicated. ACTG, there's 4 letters called nucleotides. They're wound together in a double helix. And they're wound tightly together. So you can see they're spooled together, they're clustered tight until it's time to read the gene. So how do we know, how does the body know which gene to be reading or not reading? That's the epigenome, which sits on top of the genes. And it's regulated by these epigenome regulators, these chemical tags. So if you look at these chemical tags on your genes, it basically, it's like a bookmark in a book. It says, read this page. Oh, but don't read that page, right? So when you have the right bookmarks, you read the right genes. If you have the wrong bookmarks, or if they're in places they shouldn't be, or get silenced, or they get activated, you can turn on all kinds of bad stuff. And what's really amazing, this is mind-blowing to me, in every cell of your body is the entire blueprint for every part of your body. So in your skin cell is the blueprint for your brain, or your kidney, or your liver. And we're going to get into why that's important and how we're learning to unlock that ancient code and reprogram cells back to their original embryonic state to create a brand new you. This is like sci-fi stuff. It's coming. We're not there yet, but it's being done on animals, and it's mind-blowing. I mean, we literally can use these regulation of our genes and reprogram them in ways that we just never thought possible. So when your genome is properly tagged, then you know which genes to turn on or off. And everything we do controls our epigenome. Every thought you have, every bite of food, every step you take, every relationship you have, the environmental toxins we're exposed to, our microbiome, everything is constantly communicating, saying, oh, do this, do that, do this, do that, turn on this gene, turn off that gene. So we want to make sure we're turning on the right genes. Now this is a little complicated, but it explains how these DNA methylation tags regulate our genes, either silence them or turn them on. So DNA methylation is essentially this process that happens in your body. This is where it gets a little geeky, but stay with me, I hope you'll understand it. DNA methylation is a critical part of regulating your gene expression. There are other factors that control epigenetics, acetylation, other things, but DNA methylation is the most important. So DNA methylation is this critical process that happens, that's influenced by everything in your life. And it's influenced by your diet, by exercise, by your intrauterine exposures when you're being formed as a baby, by environmental toxins. And there's so many positive ways to influence it, but there's also so many negative ways. And it's fascinating when you understand epigenetics, because it can be inherited transgenerationally. We know, for example, that if we expose rats or mice to glyphosate, which is a herbicide that's ubiquitous, 70% of all crops in the world have it, it causes generational trauma 2 or 3 generations down. So if the grandmother mouse had a problem with exposure, but the granddaughter mouse didn't, the granddaughter mouse's genes are marked with the toxicity from the glyphosate, which then causes cancer and hormonal dysregulations and all kinds of stuff. We know, for example, from concentration camp survivors that their offspring have imprints on their DNA from the epigenome that regulate their emotional framework, and loss often leads them to be more anxious and stressed and have PTSD, even though they weren't subject to anything in a concentration camp. So those marks are there, and they can be generationally transmitted, but they can also be undone, which is amazing. So we have to think about aging in a little bit of a different way. Our chronological age we can do nothing about. I was born in 1959. I'm 62 years old today. There's nothing I can do about that. Unless I go into space like Matthew McConaughey in Interstellar and I come back at a different age because of the time-space continuum warp. But there's your biological age, which is your real true age. It's the health of your biology. And they're not the same. You can be 60, but be biologically 30. Or you can be 30 and biologically 60. Now, what's amazing is even a couple of years ago, we couldn't measure your biological age effectively. Now we can measure your biological age using these clocks, these aging clocks we call epigenetic clocks. So we can measure your epigenome and how the epigenome changes over your lifetime and measure the methylation patterns on your epigenome that correlate really tightly with your age. Not only that, we're finding out through specific interventions that we can reverse your biological age, which is so cool, right? Meaning you don't have to be the age that you are, you can be younger. And my goal is, as I get older, to get younger every year. That's my goal. So measuring these methylation clocks is as a tool. Now we still don't have the perfect biomarker for aging, and I've measured 5 different companies that measure methylation clocks, and I'm waiting for the results to come back. But basically, I'm going to see, what is my methylation age? And then you can do interventions and track the interventions. Again, it's looking at how these various things happen in relation to the hallmarks of aging, what we can do to influence them, that can change our biological age. The things that cause harm to our epigenome and to our biological age are ultra-processed foods, which is 60% of our diet. If you're a kid, it's 67%. It's all the food-like substances that are often highly processed ingredients from wheat, corn, and soy turned in all color, sizes, and shapes of extruded colored products that are actually not food. And this is the majority of our diet today. Environmental toxins are ubiquitous, and we're exposed to so much more than we ever were. Heavy metals, pesticides, phthalates, BPA, glyphosate, flame retardants. I mean, the list goes on, and these are just around us and in us all the time. And there's been biopsies done in fat studies where if you look at someone who's got a breast reduction or, we call it tummy tuck, which is really not actually what it is. It's like a giant, massive operation where they cut you from end to end. I've been on this operation, but they take the fat out, they send it to a lab. Every single one of us is a toxic waste dump. I mean, if we were food, we wouldn't be safe to eat, basically. A microbiome is another huge input. And we've degraded our microbiome through eating a horrible diet because the bugs in there live on what we eat. We've harmed our microbiome through C-sections and lack of breastfeeding and through taking antibiotics and taking steroid medications and hormones and acid blockers and all the things that we do in our society damage our microbiome, which determines so much of our health. If I were to take a blood sample, I'd probably find 30% of the molecules in your blood are coming from your microbiome. You have almost 10 times as many cells in you as your own cells from foreign bacteria. So you're only like, maybe 10% human. You have 100 times as much bacterial DNA in you as your own DNA. You have 20,000 genes, but they may be 2 or 3 million bacterial genes. So you have 100 times as much information because DNA produces proteins, and those protein molecules are information molecules, and they're regulating everything in your body all the time, and you're absorbing them, and they're regulating your biology. And if they're messed up, it's going to cause damage. Inflammatory foods, not just processed food, but because our microbiomes are so damaged, we've developed food sensitivities and food reactions and inflammation. I just had a friend of mine who was 65, and she's like, I'm pretty healthy, my labs are okay, but I just don't feel good. I don't have the energy, and I got a little extra weight, and I'm a little this, I'm a little that, and I call it the dwindles, And she says, can I come and do a big workup with you and see what's going on? I'm like, save your money, just eat this way, use my 10-day detox diet, which essentially eliminates all the inflammatory foods and puts in all the good foods, and just do it for 10 days. And she texted me back the other day, she's, you're right. And she's like, I feel amazing, I'm gonna do this for the rest of my life. So we're only really often a few days away from feeling good if we learn what to do. And of course, it's not just the abundance of the wrong stuff, it's the lack of the good stuff, the protective foods. Because if food is information, food is medicine, then what messages are we giving to our biology every single bite? That determines it. And the last thing that really causes massive damage to our biology is loneliness, is isolation, is lack of community, connection, right? These are important ingredients for health. They're not optional. I mean, if you take they've done these studies with animals, with monkeys, with mice, and you take the same genetic mice, you feed them exactly the same thing, give them the same environment, except one gets affection and cuddling and all the social interactions, the other one doesn't. The one that doesn't just ages super fast. So these hallmarks of aging are the framework that we're going to talk about and how we use functional medicine to actually modify these different things in your biology. And so a lot of the aging research is actually still a little bit whack-a-mole. It's like, let's figure out how to work on mitochondria, or let's deal with nutrient sensing, or let's figure out how to fix epigenetic changes, or let's how to extend our telomeres, right? That's all good. And a lot of the things work on multiple pathways, but we have to go meta and think about that. I mean, telomeres are a great example. Elizabeth Blackburn won the Nobel Prize for discovering telomeres. And she's amazing. And they've done studies showing that meditation or a multivitamin or exercise or all kinds of things that we know are good for us actually help with lengthening our telomeres. But the things that cause the problems are our diet, leading to this pandemic of diabetes. When I said 88% of Americans are metabolically unhealthy, this is what they have. They have this extra visceral fat, this organ fat that drives inflammation and drives disease. And that inflammation is causing so much damage. They're often calling aging inflammaging. It's one of the hallmarks of aging, which is this progressive, inexorable, inflammatory state that we find ourselves in. So at the same time, our immune systems are causing inflammation as we age. Other parts of our immune system are not working as well. Why we see people who are elderly get cancer, or who have more likelihood of dying from pneumonia or the flu or COVID. It's because part of their immune system is being suppressed by our lifestyle. And inflammation underlies every single one of these chronic diseases: heart disease, cancer, diabetes. Alzheimer's is inflammation of the brain, but so is depression and autism and ADD and obviously autoimmune disease and allergies. And that leads to this phenomena called oxidative stress, which is basically like rusting. Now, we think, oh, antioxidants are the key to aging because aging is about oxidative stress. Turns out it doesn't work. They don't really work that well. And it's because we're misunderstanding oxidative stress. We need a little bit as a regulator of various kinds of pathways in our body, but not too much. And we have to go upstream to figure out what's being done. And then we have to make sure our mitochondria are healthy. These are the little energy factories that regulate our biology. And these energy factories are taking in the food that we're eating and the oxygen we're breathing, and they're producing energy, which determines everything about our health, right? If we have no energy, we're dead. If your mitochondria stop producing energy, you're dead in a few seconds, right? Why is see a 2 or 3-year-old running around like a maniac, bouncing off the walls, and a little, kind of just full of energy, and a 90-year-old kind of like moving super slow? It's mitochondria. And the mitochondria you can rev up and heal and repair. And it's fascinating how to do this. And a lot of the age-related research is on how do you regulate mitochondria, because that is the key regulator of a lot of the pathways that control aging. Telomeres, again, how do we understand the telomeres that shorten as we age? How do we influence those? How do we look at the epigenetics and regulate the epigenetics? How do we actually start to influence these hallmarks of aging, right? There's all kinds of cool stuff about how do we create mitophagy, which means the getting rid of the old mitochondria and building new ones. How do we deal with improving our immune system and improving the ability to create an anti-inflammatory system as we move towards aging instead of an inflammatory system? How do we get rid of old zombie dead cells? How do we reactivate and lengthen our telomeres? How do we improve the function of our epigenetics through various kinds of inputs, whether it's food or lifestyle or even drugs? How do we clean up old damaged proteins? How do we activate systems in the body that regulate aging longevity, the mTOR inhibition, AMPK and sirtuins? We're going to talk a lot about that. The body is designed in this brilliant way, which is, like I said, you have a recycling, cleanup, and repair crew, and you have a construction crew. And you have to activate each one at the right time in the right way to create a perfect balance of breakdown and buildup, of repair, cleanup, and renewal and rebuilding. And that's really where the functional medicine model comes in. We use this lens to start to interpret all this data because it all fits in this model. So the whole goal is to understand, one, that aging as we know it is abnormal, that it's a disease, and that we can increase our health span to equal our lifespan, and we can extend our lifespan by reversing our biological age even as we grow chronologically older. That is the future. That is where we're going. That's where we actually are right now. And I'm my own guinea pig. Like, I don't expect you to do all the things I'm doing because I'm pushing the edge a little bit, but I'm trying to see what's happening, and I'm using myself as a test subject. So far, it's working good. And you're all invited to my 100th birthday, and for sure to my 120th. But the goal for me is to actually activate this next part of my life in a way that gives me the opportunity to be and love and serve in ways that really only happen after a lifetime of wisdom and knowledge and experience. I mean, most people hit 60 and they're like, okay, time to move to Florida and go to join a golf club. I'm like, I'm not going to golf till I'm 120, okay? Like, I want to jump off out of airplanes. I want to heli ski. I want to surf big waves. I want to bike up, Haleakala Mountain. I want to do whatever I want to do and have a vital, engaged life and spend the next 60 or 80 years of my life. I feel like I'm only halfway there, being in contribution and service after you've done all the things of your career and your family and all that. Like, there's so much life left to live. And how do we then take advantage of that? And that's why when you look at the data on the economics, if you have a bunch of people who are vital and healthy and older, it adds value to society. Yes, if we all live longer and we're all sick and decrepit and had 20, 30, 40 years of decline, that's terrible. It's a disaster. But if you live the way we're living now, you're going to die long, expensive, painful deaths. But if you follow what I'm saying about extending your health span to equal your lifespan, you're going to die quickly, painlessly, and cheaply, and it won't be a burden to society.